So, good morning, everyone. Myself is Dr. Ajit Kumar, and I'm assistant professor at Presidency University in the Department of EC. So, we'll start our fourth lecture for the topic memory interfacing. So, in the last class, we have discussed about how we can interface the memory, and we have done how we can interface the memory chip with 8051 microcontroller, and we did some example also. Today we'll solve one more numerical example and then we'll stop for this topic and continue, for the next topic. So here we have a different numerical for today's class. So the numerical, the problem statement is mentioned here. What is that one is we have to design a microcontroller system using 8051 microcontroller, 4 kilobytes of ROM, 8 kilobytes of RAM, interface the external memory such that the starting address of ROM is 100H and RAM is 300H. Okay. So here the starting address is given and we have to interface this 8051. Okay, let us assume that this is 8051 microcontroller. Okay, let's say that this is 4 kilobyte of ROM, or better consider this as a ROM. Okay, a RAM. So this is, let's say this is our RAM. Okay, what is this RAM? 4 kilobytes. Okay, so this is 4 kilobytes of RAM and this is the ROM whose capacity is 8 kilobytes. Okay, so we'll interface these two memory chip with our 8051. Okay, so we know that there will be address decoder circuit which is going to select the CS pin. Okay, so we are going to have here CS pin. We know CS means chip select pin. So in both cases, there will be CS pin. However, at a time only one of the either RAM or ROM will be enabled. Okay, so for that purpose, we have to design address decoder circuit here. Okay, so this approach is little bit different. Okay, here what is to be noted is that for each memory chip, okay, this ROM, okay, that is for this ROM, the starting address is given, and for the RAMs also starting address is given. Okay, so what I will do is we'll start in the reverse order. Okay, what is that reverse order is? We'll write here. Okay, we'll write there this memory table in which we will write all the bits A0 to A50, okay, for RAM and ROM both. Okay, so let's say here what I'll do is for RAM, let's say this is A15. Okay, so let us start to see that how what is the effect of the starting address. Okay, so A15, A14, A13, A12, A10, A9, A8, A7, A6, A5, A4, A3, A2, A1, A0. Because I know that there are total 16 bit, okay, address size for 8051 microcontroller. So we have to see this. Okay, so what I'll do is I will here I'm going to use for RAM. Okay, so for RAM, I will use for RAM. I'll see what is. I'll write the starting address and end address for each one of these. Okay, uh, end address is supposed to be written. Okay, logically that we'll see. So what is given is starting address is given. Okay, so let's say here. Um, okay, so let's say here I'm writing starting address SA, starting address of RAM. So starting address of RAM is C000. Okay, now so C means 1100. This is C, and the rest bit is zero. So 000000000. This is the starting address. Okay, this is the starting address of RAM. Starting address of RAM. Similarly, we'll write the starting address of ROM. Okay, so here let's say uh, I'll draw one line which will separate this RAM and ROM memory mapping. Okay, so for the ROM, starting address given is For the ROM, starting address given is 1000. Okay, so 1 in hexadecimal is written as 0, 0. Okay, A15 0, A14 0, A13 0, A12 will be 1. Okay, this is 1, and the rest bit is 0. A10 0, A90, okay, then A80, A70, A60, A50, A40, A30, A20, A10, A00. Okay, so this is the starting address of the ROM. Okay, so this is starting address of ROM. Fine. Now, end address we'll write here. Okay, end address we'll write here for each one of this memory chip. Okay, so what I'll see is now to write the end address, we are supposed to find that how much, I mean, how many address lines will be required for each one of these. Okay, so see here, uh, what is that will be decided by the memory chip capacity. Okay, so for the RAM, the memory chip capacity is 8 kilobyte. Okay, so for RAM, I'll write here for RAM, the capacity is the memory chip capacity is okay. Memory chip capacity is given as 8 kilobytes. Okay, so what I said, to find the number of address line. Okay, to find the number of lines required, address lines required to interface directly with 8051. Okay, to interface directly with 8051. So I told you that what is the approach for this one. Okay, so you do one thing, write this 8k in the power of 2. So 8 is 2 power 3, k is, k is 1024 bit. Okay, so this is written as 1, sorry, in the power of 2, it will be written as 2 power 2 power 10. So total I got 2 power 13. It implies that we need 13 address lines. 13 address lines, that is from A0 to A12. Okay, which will be directly interfaced. Okay, which will be directly interfaced with 8051, and the rest bit. Okay, the rest bit means A13, A14, A15 will be connected with address decoder circuit. Okay, so these are unutilized address line. Okay, these are unutilized. Unutilized. I told you that these unutilized will be connected. Unutilized address lines, okay, will be used, or you can say will be connected to address decoder circuit. Will be connected, will be connected to address decoder circuit. So that address decoder circuit you can take, I mean, design in any way. I mean, by either okay, this address decoder circuit you can design either by OR gate, okay, or using AND gate. Okay, using NAND gate. Okay, we have various, we can use any gate. However, the logic is that the output of this OR gate should be 0, so that 0 should be received by the chip select input of your RAM, so that the RAM is enabled. Okay, similarly for ROM. Okay, so for ROM, I'm going to find the number of address lines required. Okay, so how much is the memory chip capacity given for the ROM is 4 kilobytes. Okay, so for the 4 kilobytes, this is the memory chip capacity given. Okay, so 4 kilobytes. Write this 4k, that is 4 into 1024 in the power of 2. So 2 power 2 into 2 power 10. So this is 2 power 12. So this 12, okay, this 12 will be used as address lines. Okay, so 12 address lines, 12 address lines will be, okay, same this. Okay, required is required, okay, to be directly connected, to be directly connected with, when I'm saying directly connected means still there will be latch which is going to demultiplex the address bus data bus with 8051. Okay, and the rest that is 12 address line is A0 to A11. Okay, this will be directly connected, and then A12, A13, A14, A15 will are unutilized. Okay, unutilized, and okay, unutilized. So they will be connected with address decoder circuit. Address decoder circuit. Okay, address decoder circuit. Again, this address decoder circuit could be any gate. Okay, you can implement using any gate. Fine. So this one we will see. So now what I will do is we will segregate the complete address line into two parts. That is utilized, the one which is going to be directly connected, and unutilized which will be connected as input. Okay, so for the RAM, you see where the segregation happens from A0 to A12. Okay, and then A13 to A14. So A13 to A15 for the RAM. Okay, so I'll do one thing. Here I will segregate this into two part. So that is for the RAM. Okay, these are the unutilized lines. So they'll be used for the address decode circuit. Okay, so this so I'll just circle them and say that okay, for this will be connected to address decoder. Okay, for which one? For RAM. Okay. Now for the ROM, similarly, you have to segregate. So for the ROM, we have seen that A12 to A50, okay, they are going to be utilized as input to the address decoder circuit. So for a ROM, it will be starting from A12. So what I'll do, I'll segregate this like this. Uh, do one thing here because our ROM is here. Okay. I'll do one thing. Uh, Here I'll separate. Okay, so let me write here also, that is A15, A14, A13, A12. Okay, they will be connected as input, okay, as input to address decoder circuit. Address decoder for ROM. Okay, so I'll do one thing. This end address I will write here. Okay, sorry. End address for, now we can write the end address quickly. Okay, end address for the RAM and the end address for the ROM. So recall, okay, what I said is if I'm going to write the end address for the RAM, okay, so we know how we can do. The one which is connected directly will be in the range of address. They will vary from all zeros to all the ones. Okay, so this was the starting address. Okay, so let us make it smaller. Okay, so this was the starting address. Now I'm going to write the end address. So end address, I'll write in the black font only so that I can show you this proper segregation. So the end address means all this, okay, all this will be varying from all the zeros to all the ones. Okay, so this was already explained in the previous lecture. So I will write all these as ones because I know they are going to be directly connected here. So I'll write one here. Okay, one. Fine. And these unutilized, okay, this unutilized will be fixed. Okay, this has to be fixed, so that one has to be fixed. Okay, this must be fixed here. Okay, and that is already given. Okay, that it has to be A15, A14, A13 because you recall that these unutilized address lines are not going to change for the starting address as well as the end address. They will remain fixed. Okay, so once it is given in the question that starting address is C, so C means that we know A15, A14 is 1, A13, A12 is 0. Okay, so this one was already given in the question. Okay, so this one was already given that it is supposed to be C. Okay, so C. So in that case, this unutilized address line is not going to change. Okay, so what I will do is I will write them as same. Okay, so A15 will be still 1, A14 will be still 1, A13 will be still 1. Okay, now A12 is not unutilized. Okay, this A12 is directly connected because just recall, see here what we have seen is a naught to A12. A naught to A12 are directly connected. That is why I made this A12 as binary one. Okay, so don't get confused that why you have not written this 0. Okay, I hope it is clear to you. Similarly, come to the ROM. So in the ROM, again, where the segregation happens, A naught to A10, okay, they are directly connected. So we have seen here for the ROM, we have seen 12 address lines are required to be directly connected with 8051. That is A naught to A11. Okay, so A naught to, okay, one thing I missed here, I think. So 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, one bit I missed here. That is A11. Okay, so I'll do one thing. Uh, A10. um, right here, 2 bits. Okay, that is A10. So I write here A10, A11. Okay. Now A10 is 0 starting address, A11 is 0 in starting address for the RAM, and the end address will be A10, 11, A11, 1, and A12 of course 1. Okay, this was the case here, and then come back. Okay, so let us see this segregation here. So the segregation for the ROM happens between this 12 and 11. Okay, so we know A10 to A11 will be directly connected, A12 to A13 will be connected to address decoder. So it is between 11 and 12. So I'll make, already we have made this partition here. If you see in the green text, okay, we have seen this A11. Okay, this is the segregation for the RAM. Okay, so in that case, this A10, okay, that is A11, sorry, A11 to A naught. Okay, they are directly connected, okay, for the ROM. Okay, so here I'll write this bit. Okay, this A11 also 0 as starting address. Okay, now recall what was the given address was starting address given for the ROM is 1000. For that purpose, this 0001, okay, will be fixed. Not only this one, up to yeah, up to A12 it is supposed to be fixed. From A11 to A10 it can vary. So the end address, there A0 to A11 will be 111. Okay. Okay, this is the end address. Okay, and this was the end address for RAM. Okay, now this is supposed to be fixed. Okay, because it is given in the question. Okay, so I'm not going to change this 0001. Okay, now already we got the answer. Okay, what is, I mean, how the address decoder circuit is going to look for the RAM. What I'll do is the address decoder circuit will be having the input as A15, A14, A13. Okay. Whereas for the ROM, the input to the address decoder circuit is A15, A14, A13, A12. Okay. So from this context, if you see, uh, I'll do one thing. Okay, uh, like this. So let's say that the address decoder circuit. Okay, address decoder circuit for I'm just drawing here. Okay, just for the sake of explanation. So let us say this is OR gate. This is OR gate for RAM. Okay, address decoder circuit for the RAM. The input will be A13, A14, A15. Okay, A13, A14, A15. Okay, so A13, A14, A15 are the inputs, and what is given is A15 is binary one. Now recall this output should be definitely zero. Otherwise, our RAM won't be selected. The chip select input of the RAM should be zero. So from that context, if A13 is given as zero, A14, okay, let me do one thing. So, okay, this is A13, A14, A13, A14, A15. Okay. This is A13, which is uh oh this is supposed to be zero. Okay, this is supposed to be zero. And this because from 13, 14, 15 it was given as we got this as fixed no. They are inputs. So 110 is for the starting address also, 110 is for the end address also. So A13 is zero, we will connect directly. Okay. A14 is 1. So A14 is 1. Okay. Now this one, if it goes as input, okay, then this output of OR gate will become 1. So I will connect one NOT gate here. I will connect one NOT gate here. Like this. Okay, let me draw this something like this. So I'll draw A14, which is 1. Okay, as input, I'll pass this one with a NOT gate so that the input will be 0. Okay, and then A15 is also 1. Okay, you can see A15, A14 both are 1. So here A15 is 1. So again, I need to pass this one with with NOT gate so that this should become 0 and this OR gate should be in output should be 0. Okay, so this 0 I mean the logic is this one. The logic is that output should be 0. Output should be 0. Okay, remember this. Okay, and accordingly you have to see that what should be the input, whether the NOT gate should be there or not. This has to be decided from your end. Okay, so for similarly, this was for the NOR or RAM. Similarly, for the ROM. Okay, so for the ROM, let's say this is the OR gate for the ROM. Okay, now see here. mm, Now you can see A15 is 0, A14 is 0, A13 is 0, A12 is 1. Okay, so I'll draw here four inputs. That is 1, 2, 3, 4. That is A13 is 0, no issue. 0 as input, no problem. A14 is 0, no issue. We'll connect this as directly. 13, 14, 15. Okay, okay, wait, just one minute. Uh, so this is the OR gate, that is address decoder circuit for ROM, whose input should be from A12 to 15. Okay, so A12, you can see A12 is 1. So this 812, I'm not going to. So A12, I'll connect with a NOT gate here. Okay. Then A13 is 0, so I'll connect directly. A14 is 0, so I'll connect directly. A15 is 0, so I'll connect directly. Okay, this is that input of the address decoder circuit, so the output will be 0. Fine. So let us connect this address decoder circuit here. Okay, and all our work is almost over now. Okay, so what I'll do is I'll connect here. What I'm going to do is now I'm going to make it large, okay, and redraw it. So, 1 minute. So let us drop this OR gate, okay, and what I will do is one output of OR gate will be for the CS and another output of the OR will be for this ROM, okay. So I'll connect two OR gate here. I'll draw two OR gate. Uh, let's say here, recall from port 0, okay, that is from port 0 dot 1, okay, to port 0 dot 7, okay, they are multiplexed. So multiplexed means AD7, AD0, okay, this is the NOT gate. So this is the OR gate, okay, now, okay, we are supposed to pass this through latch. Okay, so I'll draw here latch. And the output of this latch will become A0, A0 to A7. This A0 to A7 is directly connected here. Okay, fine. To ROM, and the same A0 to A7 is also connected. A0 to A7 is also connected. Okay, like this. So now remaining, that is port 2.0, port 2.1, port 2.2. Okay, okay, they are like higher order address bus, that is A8, A9, A10. Okay, so just come back to this one. For RAM, what we have seen is up to 8, up to A12 it should be directly connected. So A10, then A11, A12. Okay, they are going to be directly connected here, like this. That is A8 to A12. Okay, now for this one. Mm, for ROM, it is up to A11. Okay, so I'll do one thing. I'll show here the same wire. Okay, will come here also. That is A8, okay, A9, A10, A11. Okay, they are directly connected, so you can assume that this same bus is coming here and getting connected here. Okay, now A13, A14, A15. Okay, for the this RAM will be connected with the, so you can connect A13, A14, A15 here. Okay, they are going to be connected direct. Now recall what we have drawn for the RAM. Okay, for the RAM, A13 was directly connected and 14, 15 is connected through the OR gate. Okay, so A13 direct connection, A14 NOT gate. Okay, A15 through NOT gate. Okay, they are the inputs. The output will be 0. So you can connect this for the chip select input. Okay, we have already drawn this Okay, no problem. I'll write here CS input. Okay, erase this previously written. Okay, so our RAM is selected by this. Okay, now similarly for the ROM, the unutilized were 12, 13, 14. Okay, and we have already drawn here. 8, 12 is connected through the NOT gate, and rest 13, 14, 15 is connected. Okay, so I'll draw one more OR gate here. I'll do one thing. I'll have to erase this one. Okay, I'll draw one OR gate here. So 8, 12 from here will come through the NOT gate. Okay, you can take this connection here. Okay, this one like this and connect here. And A13, A14, A15 will be connected directly. And the output will be of course 0. Okay, because A12 is binary 1. This is 0, this is 0, this is 0. Okay, and this will be connected here to the CS input pin. Okay, so this is the logic gate address decoder circuit, and then few more that here will be output enable that will be connected with PSEN, program store enable, for the ROM. Okay, so this PSEN will be connected sorry will be connected with this OE pin. Okay, and similarly here also we have RD and okay, RD and this WR pin, that is, I'll do one thing. Let's say this is the output enable, this is the right enable. Okay, connect them with this okay, connect them here with RD pin and WR pin. Okay, so this WR pin will be connected to right enable input, and this to output enable. Okay, so this is the overall connection. Okay, so at you can see this is how it is going to be working. Okay, so this one is actually one numerical example and the last numerical example that we have done here. So in the next class, we'll discuss the next topic. This memory interfacing is over. So thank you, everyone.